Hi everyone, welcome to our lecture on feature engineering. So this is the beginning of the lecture in which I want to talk about a particular example on how to do feature engineering in this problem in which we want to predict the duration of a taxi trip in New York City. So this is a data set from Kaggle. It's a very interesting data set because it has very interesting features, also has a lot of data. Also, people have gotten this data set a few times in interviews as well. So it's kind of fun for you to see this and then say, oh, I think I know how to do it. So hopefully you will find this one useful. So let's start by, so basically if you guys wanted to follow me, stop the video right here, go on and grab this notebook from our GitHub repository and also grab the data from GitHub, data from Cal competition. So, so I have a training data and some test data. This is from the Cal competition, and you see we have over 1 million observations, so, which is great. So let me tell you what are these observations. So I have an ID, which is a unique identifier for each trip. I have a vendor ID, I have a pickup daytime and drop-off daytime, which are very useful. I have passenger count, I have pickup longitude and pickup latitude, drop-off longitude and drop-off latitude. I had some kind of flag. And finally, I have a trip duration, which is what we want to predict. So we want to use all of this data to predict trip duration. Yeah. The first thing I go around and do is to look at this data a little bit and to clean up some outliers. Since we're going to be doing regression, sometimes it's useful to do some outlier cleanup a little bit before we do our models, because our models could be um, susceptible to outliers. So yeah, so basically let's first plot some data. And here what we're gonna do is plotting trip duration. And we see here, guys, that there are some really bad kind of outliers here, right? So I am going to look at, so one thing I like to do a lot is using quantiles, especially when you have so much data. It's actually pretty difficult sometimes to actually see the whole data set, but looking at some quantiles give you an idea of how are things going on. So for example, here I have the 99% quantile is this number 3,400, like 3,440. And that is approximately 57 minutes. So, it's hard to believe that there are too many trips in New York City that are a lot longer than 1 hour. So what I'm gonna do here is I'm going to truncate some of these very long, because I think there are mistakes, and let me put just like 1 hour maximum. Also, there are some of the trips are just kind of one, you know, they're really less than 1 minute, and I don't think you can have a trip less than 1 minute. So I'm gonna just put that the minimum is 1 minute. Okay. So yeah, after I do that, then I can plot again and I get a much, kind of a better understanding of this data. So I just sorted the just to see something, because if you don't sort, you just do a scatter plot, just gonna see a lot of different, it's a lot of data, right? So you don't see very much what's going on. So after that, I am going to plot the trip duration. Like I'm gonna do some a histogram of the trip duration and a histogram of the log of the trip duration and the square root of trip duration. And I'm just kind of showing you this because, if you see the trip duration itself is a heavy tail distribution. So it's heavy to the right. So there are trips that are very long in duration. So people like to model in general variables that are more shaped like a normal distribution. So in this case, we're gonna use the log of the trip duration instead of the trip duration themselves as our target variable. Then if you want the trip duration, you exponentiate to get it. Okay. So Yeah, we're also gonna use that because that's what the Kaggle competition also does. So they model the log of the trip duration and not the trip duration itself. So okay, so we do that, and then we're gonna now compute some features around distance and speed. Okay, so the first thing we do is to compute some distance using longitude and latitude. And some of you are gonna tell me, well, but it's Manhattan and there is water in between, so you cannot just kind of go and use the distance. Sometimes the trips are gonna be much longer because you cannot go directly. But I am just gonna say that this is a rough variable, and hopefully it's gonna be useful, and it doesn't have to be perfect right now. So we're gonna go and do that, compute the distances. Then now we have here, you see the distance right here. Okay, and then let's plot trip duration against distance and see that there is some kind of good correlation. It's not perfect. We have correlation of 0.73. But it most likely is going to be kind of a good variable to use. Then after that, I am gonna try to compute some idea of speed. Okay, notice that speed is using our target variable, trip duration. So this is not really a feature by itself, but I'm gonna show you later how you can use that as a feature. We're gonna have a trick to help us use the speed as a feature. Okay, so then also let me just plot the speed itself with a box plot. You can see that there are a few kind of pretty bad outliers too here, right? So yeah, so it looks like there are some outliers. I'm looking at the trip duration against distance against here, and then I am going to compute the quantiles for speed. And then you can see here that the quantile 9.999 is 55 or 56 kind of miles per hour. So basically I am going to put everything that is bigger than 60 miles per hour. I think it just doesn't make sense, so I'm going to just put 60. Okay, so, and because also this is average speed, right? So I don't know, in New York City I don't think you can go a lot average speed much higher than 60. So let's kind of do that. Okay, next I'm going to compute a bunch of time features, and so I'm going to compute pick up weekday, pick up week of the year, pick up hour, pick up week hour. So I'm going to compute all of these features. Yeah. Oh, something. Yeah. How is that? How is that not? Okay, maybe I actually didn't. Give me one sec here. I think I probably didn't run this. Okay. Okay, now this should work. Okay, perfect. And now let me look at basically speed by pickup hour. So in this plot here, you can see that basically there are some differences by different pickup hour. You can see how you can go at bigger speeds, for example, at 4 a.m. and 5 a.m., 6 a.m. And then you have to lower your speed at 8 or 9 a.m. Things get, you have to go slower. So most likely by looking at, speed has a relationship with our variable, which is like how long it is gonna take, right? So most likely this pickup hour is gonna be kind of a useful feature. So every time that you guys want to understand if a variable that you have is useful for your target variable, you have to do some kind of plot in which if you see some kind of pattern, most likely that variable is going to be useful. Okay, so in here, for example, as I was telling you, it looks like speed at 5 a.m. is gonna go higher than at, in the middle of the day at noon, right? So hopefully that the model can pick up that. Okay, so then the next thing I want to do is kind of something very fun you can do when you have longitude and latitude, is that you can cluster spatially these points. So I'm going to compute two more features here. So I'm going to compute a cluster for a pickup location and a cluster for a dropout location. Okay, so I'm going to do that right now using a k-means. So you're gonna see that I have my clusters. You have a pickup cluster and drop off cluster. Okay, so this is a visualization of the cluster. So different colors are different clusters. Okay, you can see, for example, that somewhere down to the right here is probably one of the airports. I don't know which one it is. I haven't been there for a while, so I'll have to figure it out with a map. But so here we have the airports, here we have Manhattan, and so this is other places in which there is much less taxi traffic. Okay, so then the next thing I'm gonna do, I'm going to divide the data into training and validation. And I'll tell you why I need to do it right now before I start talking about target encoding. So target encoding is one of the main tricks I want to show you today. And in the next part of the lecture, I'll show you how to do a much sophisticated version of target encoding. So the idea of target encoding is basically to cheat a little bit, right? So suppose that think about any categorical variable. For example, in this case, think about the column pickup per weekday. Okay, so the idea is that if I, for example, can use the trip duration by pickup weekday, which I compute here. Okay, so I'm computing here a table of average speed by pickup weekday and average log of trip duration by pickup weekday. And if you look at these variables, they are gonna be a bit different. For example, I am guessing that 6 may be Saturday, or I'm not sure about that, if it is Saturday or Sunday. So, but 5 and 6 and 0 are higher than 1, 2, 3, 4, and 1, 2, 3, 4, substantially higher, right? So basically, I'm gonna tell you what I'm gonna do. So I am gonna compute this variable in my training data. So I compute this table, and then I join this table with my main table. Okay, and I'm gonna have a new variable now called average pickup day per average pick by day speed, average speed pickup day, or average long trip pickup day, right? So, and I'm gonna have these two variables. So by merging that, you are helping your algorithm a little bit, saying, hey, for this particular pickup weekday, this is the average. So use this variable in whichever way you want. Now you guys are gonna tell me, how can I compute this variable in a test data in which you actually don't have the trip duration? What we're gonna do is going to take this table that we computed with the training data, and we're gonna impute these values in our validation and test data. And in that way, we're gonna be cheating a little bit by taking the things we have learned with the log of the trip duration from our training data and putting it in our validation and testing data. Okay, so and in that way we are helping a little bit the algorithm learn about these variables. So Um, okay, so then I can do the same with any categorical variable, really, right? So I can do basically what is the average log trip duration per pickup cluster, or the average speed per pickup cluster, right? And that would becomes another variable. Or I could say what is the average speed per pickup cluster and drop off cluster, and that becomes another variable. Okay, you have to be a little bit careful with these variables because they are so good that sometimes they overfit. So I am gonna show you a trick in the next lecture on how to compute them so that they overfit less. But so you have to be a little bit careful with them and how many of them you want to have in your training in your data set. But they are quite useful sometimes. So I'm going to basically okay, maybe I haven't really run this. Okay, I think I have to go back and maybe not in index. Okay, so I guess I haven't really run this before. Sorry, right here. So let me restart it for a second this and run a few things kind of quickly. Okay, sorry about that. Let me okay. Now we compute these features. Okay. Okay, so hopefully it's gonna run right now. Okay, great. So basically now we have computed these features: log of trip duration by drop-off cluster, uh, speed by drop-off cluster, log of trip duration by pickup cluster, and speed by pickup cluster, log of trip duration by pickup week hour, and so on. Okay, so we're computing some of that. Now we are going to compute, we're gonna do the same thing but compute for pairs of variables. So for example, pickup hour and pickup cluster, pickup hour and drop off cluster, or pickup cluster and drop off cluster. So I'm gonna go, and the first thing I do is I go and compute this table, and then I merge that with the whole with the whole training data, okay, and validation data. So remember, I compute the table on the training data, okay, and then I merge the table with the training data and the validation and the test data, okay. So let's just do that. Okay, so we compute that, and then let me just kind of show you here how, when we do it for two different variables, how it looks like. So we have here pickup hour 0, pickup cluster 0, the speed is 17.9. But then pickup hour 0, pickup cluster 1, the average speed is 41. So that is a very big difference, right? So we have pickup hour 0 and pickup cluster 4, the average speed is 33. So hopefully this variable is going to be useful, right? Okay, so okay, so this is an example, and here's another example between pickup hour and pickup okay, so basically here I'm computing the median instead of computing the mean. So there is nothing special exactly about the mean, but you can also compute the median. So that could be another example. You can compute the maximum, the minimum. So whatever you guys want that is useful, you may be useful to compute, right? So then, so it may be that in some cases, when you compute uh, when you have too many different pairs, you're not gonna have some of the some of the values are not gonna be there. And basically, when you have this, you're gonna create some kind of NAs, right? So when you have NAs in your data, what you're gonna have to do is to take the average, just the average of the variable that you're computing. For example, if you're computing speed, then you take the average speed over the whole data set, and then that will be the value that you put in there, okay? So yeah, so basically I'm gonna fix the NAs here by using the mean of whatever column you are computing against the whole data set. Okay, for example, in this case, I take the speed pickup cluster, drop off cluster, and I compute the mean of that. And if I see NAs on that new variable, I'm just gonna fill with the mean. Okay, so let's just kind of do that to fix all of the NAs. And yeah, so just kind of do that for everything. So next, so here I have 39 columns, and I basically went and picked some columns for you guys so you can look at all of them here. And I am about to basically train on this data with XGBoost. Okay, so there are different ways of querying XGBoost, different APIs. It's the same package, but there are different APIs to do it. And I like using this particular API, in which, you know, here you have different parameters that you need to choose. We're gonna talk about gradient boosting a lot later. So here I'm just gonna give you an example, and then later on we're gonna talk about what all of these parameters mean. I can tell you a little bit. For example, max depth is just the depth of the trees. So XGBoost is an ensemble method in which, similar to random forest, but it's trained in a very different way than random forest. But what you're gonna have is that your predictions are gonna be the average of predictions, or the sum of different trees. So it's a sum of the over different trees. So max depth is the maximum depth of a particular tree. The evaluation is on RMSE. The objective is the square error. Yeah, everything else, let me tell you more about it when we talk about gradient boosting. So basically here what I'm gonna do is I am going to say, well, this is my target variable, is the log of the trip duration. This is my validation target, is right here. And then I am going to use this D matrix from XGBoost to tell which are the values of my variables. These are the features that I have, and which is my label. Okay, you're gonna do that for the training, the validation, and the testing. Yeah, so let's just kind of do that. These are some of the values that we have here. Okay, and then basically you kind of go ahead and train this and basically train on this. Then whenever you want to make predictions, actually let me train, you do basically GBM, you call GBM this XGBoost.train here. So you do GBM dot predict. You can make on your validation, for example, you can make predictions. I am using scikit-learn to compute R squared. Remember that I told you that every time you're doing regression, it's kind of good to check your R squared. In this case, my R squared is 0.8, which is, you know, decent. And here is basically how you go back to your prediction by exponentiating. I don't know why I have this -1 here. You can compute feature importance. So here is my feature importance table, in which, you know, pickup latitude was this basically the feature with the larger importance. Then we have pickup longitude, drop off latitude, drop off longitude. Then you have the speed. You remember that we compute these kind of speed variables that are kind of useful. Um, then then some of the cluster seem to be useful. The distance seems to be useful, and so on. Okay, so yeah, so this is it. And if you guys have any questions, we're gonna talk later this week. So see you then.